All right, now that we've got diffraction and polarization under our belts, let's talk about reflection and refraction. So reflection is when a wave bounces off of a boundary. So that's when it's trying to go from one medium to another. The one you're obviously most aware of is a mirror. Light is going from the air, it hits the mirror, it reflects back off of it, the light comes to our eyes. We're going to do this using slinkies. So leave some space in your journal or wherever you're taking notes. Put about 5 lines of space here so that you can draw a couple of demonstrations. We're going to have slinkies where there's a fixed end, meaning you just hold on to it. Someone sends a wave at you. Then we're going to do one where we just have the end of the slinky on a string, and that string allows it to be free to move, and then we'll see what the difference is between them. Additionally, we'll do the same thing, but we'll do it with different types of media, meaning the medium that the wave is traveling through, the slinky, is going to change. We'll have a slinky attached to a really thick coil, and we'll see what the waves do when it goes from one to the other. I'd leave about twice as much space for this one as you left for that one. If you want to be safe, leave like 10 lines and 20 lines. You can draw your diagrams really big. But additionally, with this one, we're going to have a chart where we're looking at how the reflected and transmitted waves look for their wavelength, frequency, velocity, and amplitude. Cool. Now, when the wave does change medium, and this will give you a hint, normally we would do the demos before we got to this, but with it being online, this is how we have to do it. So when the wave changes medium, the velocity of the wave is going to change proportionally to the density. Let's say that again. The velocity of the wave is going to change according to the density. So frequency is a thing that will never change with a wave. Based on that, since our velocity is changing, and we know our wave equation is velocity equals frequency times wavelength, if frequency is constant and velocity is changing, wavelength is going to have to change proportionally. So what that gives us here is that when we change media, these two will always stay proportional to each other. This guy will always be a constant. So it's always a constant the whole way through. Now, the effect of your velocity and wavelength changing, this is what's called refraction. And we'll see that as we go through a few more labs with it. So let's take a look at the different terms that we've learned. Let's go through them and make sure we understand what they are and how they relate to different types of waves. The first one is reflection, and reflection, remember, is just a wave bouncing off a new medium. It hits it, comes back. This works for both light and sound. This is how you get echoes, and that's how you can see your reflection. Diffraction is a wave passing through an opening. This is where waves go through an opening, and as long as their wavelength is similar or smaller than the opening, they're going to bend as they go around the corners. And this works for both light and sound. This is why you can hear around corners and why you get weird wave patterns, which we'll talk about later as we get further into light, as light passes through openings. Refraction is when a wave changes medium and the bending that happens because of it. We'll talk a little more about that too when we get into more light patterns. But remember, this works for both light and sound. This would be like if I screamed underwater and you could hear it out of the water. The speed of sound changes in those different media. Same thing works with light. As light passes from above in the air, as it goes down in the water, it's going to get some bending. Polarization is a wave being filtered only into one plane. Now, compressional waves aren't in planes. It's traveling through the medium, whereas with transverse, they're going up and down. This one only works with light, does not work with sound.